NAT Gateway is a fully managed NAT service to allow instances in your private subnet to establish outbound connections. And as you can see here, we have a NAT Gateway in a public subnet, but technically they can be deployed in a private subnet. And that wasn't always the case, but they've changed it since the last time I've used NAT Gateway. A NAT Gateway is redundant within a single subnet, meaning you'll need a NAT Gateway per subnet. And the issue with this is it can add up costs pretty quickly because as long as you have a NAT gateway deployed, it's going to cost you money, even if you're not using it. So if you have a workload, let's say in 3 subnets, then you're going to be paying for 3 NAT gateways, and for that's 730 hours for each of those. It's going to add up to $98, and that doesn't even take into account the data processing cost for data passing through it. So NAT gateways can be expensive, and is something that companies are always having a hard time with, especially at the enterprise level, because it's just when you want everything to secure, you got to have NAT gateways for IPv4. So that is a challenge for some folks to mitigate. NAT gateway has 2 connection modes: public, which is the default. This is where instances are in private subnets and can connect to the internet through a public NAT gateway, as demonstrated in our diagram there. They cannot receive unsolicited inbound connections from the internet, which is what we want. You must associate an elastic IP address, so that is an additional cost because that EIP has an IPv4 cost. So small, but it is a cost that you have to consider as well. Then there's private. I don't remember private existing before, so I feel like this is new. Instances in private subnets can connect to other VPCs or your on-premise network through a private NAT gateway. You can route traffic from the NAT gateway through a transit gateway or a virtual private gateway. You cannot associate an elastic IP address with a private NAT gateway because it's private. If it's public, then you can have a public elastic IP address. It makes sense. There's probably a little bit more nuance to this, but it's not going to show up on your exam, so we're just keeping it straightforward here. There is these things called DNS64 and NAT64 because IPv6 is just the future. I figured we should throw this stuff in here, even if it doesn't show up in the exam. So this is straight from the documentation. Let's just read through it and understand what's going on here. So a NAT gateway supports network address translation from IPv6 to IPv4, popularly known as NAT64. And we said that NAT can't do address translation for IPv6, which is true, but it can do IPv6 to IPv4. So just understand that distinction there. So what is DNS64? Your IPv6 only workloads running in your VPC can only send and receive IPv6 network packets. Without DNS64, a DNS query for an IPv4 only service will yield an IPv4 destination address in response, and your IPv6 only service cannot communicate with it. To bridge this communication gap, you can enable DNS64 for a subnet, and it applies to all the AWS resources within that subnet. As far as I understand, there's no additional cost to this because I couldn't find any. What is NAT64? NAT64 enables your IPv6 only service in Amazon VPC to communicate with an IPv4 only service within the same VPC or connected to VPCs in your on-premise networks or over the internet. The last one sounds extremely useful, but yeah, there you go.